In this video, we're going to look at a situation where just a constant is not going to fix our problem. So let's look at this. We're trying to find the antiderivative of x times the square root of 2x minus 1. So if I let u equal the inner function, 2x minus 1, du then is 2 dx. I don't have a 2 as a coefficient anywhere in my, or a constant in my integrand, so I'm going to multiply both sides of this by 1/2. Okay, now I can make some substitutions. I've got this x still, which I'll have to think about here in a minute, u to the 1/2, and then dx becomes 1/2 du. If I pull that 1/2 out in front of the integral, I have an issue. I cannot find the antiderivative of this because I have two different variables. I have x and I have u. So we're going to have to somehow replace x or change x so that it's also a function of u. I'm going to give you about 2 seconds to think about that. Okay, maybe 10. How can we rewrite x as a function of u? This equation that we first set up above, u equals 2x minus 1. If I manipulate that equation and isolate the x, then I'll be able to write x as a function of u. So I've got 2x equals u plus 1, and if I divide everything by 2, x equals 1/2 u plus 1/2, or half of u plus 1. So if I rewrite this here, then I've got 1/2, and then I have 1/2 u plus 1, u to the 1/2 du. You can pull that 1/2 out as well with the other 1/2. So if I pull out this 1/2, since it's just a coefficient, I'll make this 1/4. And now I've got u plus 1 times u to the 1/2 du. We still have a little bit of an issue here because we don't know how to find an antiderivative of a product like that. So we cannot just find the antiderivative of each one of those separately. There's no antiderivatives for a product. I'm saying it again, there is not an antiderivative for two things that are being multiplied together. So what we can do, though, is distribute this in. So that gives me u to the 3/2 plus u to the 1/2. And that's all multiplied by du. Now I can find the antiderivative. Okay, so if I find the antiderivative, add 1 to that, that's 5/2, so that's u to the 5/2. 1 divided by 5/2 is 2/5, plus add 1 to that, that's 3/2. 1 divided by 3/2 is 2/3, plus a constant. If I distribute the 1/4, I end up with 1/10 u to the 5/2 plus 1/6 u to the 3/2, and then 1/4 times a constant will still be a constant. All right, so to clean this up then, I'm going to change the u back to what we started with, and I'm going to make this just another constant. I don't need that 1/4 there. So I've got 1/10 2x minus 1 to the 5/2 plus 1/6 2x minus 1 to the 3/2, and then plus some constant. Okay, so that's how we take care of that extra x. Notice I didn't just multiply. Let me get a different color so I can show you where I'm at. Notice that I didn't just say, oh, well, I've got an extra x in there, so I'm just going to throw an x in this, here and here. Because if I do that, I mean, first of all, that's changing the entire integrand because we are throwing in a separate variable. And secondly, we would end up with with this x that could be 0, that would change everything. So we can't not just change this du by multiplying in a variable. The only thing we can change about du is multiplying by a constant. So this is never okay. If you're trying to manipulate this du with a variable, you need to stop yourself because it is not okay. A constant only. So the extra variable had to be dealt with this rearranging of the problem. All right, so I'm going to give you one to try then. I want you to try this. See if you can go find that antiderivative. Pause this. Go try it. All right, I hope you paused and that you actually tried it. So what I notice here is that we've got an inner function. U is equal to 3x plus 1. U prime, or du, is 3 dx. We don't have a constant of 3. We do have a constant that is, or a coefficient that is 2. So if I multiply this by 2/3, and if I multiply this by 2/3, I can do some rewriting now. So this x and 3x plus 1 squared, if I move that 2, so make it like 2 dx like this, then I can make some substitutions. I still have this x, we'll deal with that in just a second. U was 3x plus 1, so that's u squared, and 2 dx becomes 2/3 du. All right, we still have that x to deal with, so I'm going to rearrange this equation. I'm going to isolate x, so I know that 3x equals u minus 1. X is equal to 1/3 times u minus 1. All right, if I throw that 1/3 times u minus 1 in for x times u squared times 2/3 du, I'm going to pull those constants out. So 1/3 times 2/3 is 2/9. I'll pull the 2/9 out. And now I've got u minus 1 times u squared du. Can we find the antiderivative with a product? Oh, no, we can't, can we? So let's distribute this u squared in. U cubed minus u squared du. Now I can find the antiderivative because this is more like a polynomial, just working backward from the power rule. So the antiderivative of u to the third is 1/4 u to the 4th, and then u squared would be 1/3 u cubed plus a constant. Multiply the 2/9 through, so that gives me 1/18 u to the 4th minus 2/27 u cubed plus 2/9 times a constant. Okay, let's simplify this. Let's replace u with what we started with and make that c just still a constant. So we've got 1/18 3x plus 1 to the 4th minus 2/27 3x plus 1 cubed. And 2/9, which is a constant, multiplied by another constant, is still a constant. Okay, now I want to work out one problem from your homework tonight because the wording is a little bit strange, and I just want to be sure that you understand the wording. We're going to do 61 together. This is from your homework. 61 says, find an equation for the function f that has the given derivative and whose graph passes through the given point. So we're saying here's the derivative. It's the negative sign of x over 2. And the original function passes through the point 0, 6. So what they're saying is find f of x. And because they tell you a point that f of x passes through, we also need to find c. So let's see if we can do that. To find f of x, we need to integrate this. And instead of x over 2, I'm going to write this as 1/2 x. Makes it a little bit easier to understand. I'm going to be lazy and not put the dx. I'm going to use a different color to show my substitution. I see an inner function, u equals 1/2 x. The derivative is 1/2. Let me clear that up. Sorry, I get lazy, but I shouldn't get lazy. Du equals 1/2 dx. Now I don't have a dx in here, but I'll add one so that we can do our substitution like we need to. I do not have a coefficient that is positive 1/2. What I do have is a coefficient that is -1. I'm going to All right, I'll do that. So we do have a coefficient that's -1. This is going to mess us up later, but I'm going to do it anyway. So I'm going to multiply both sides of this by -2 du equals negative dx. All right, making the substitution then, I end up with the sine of u times -2 du. I'm going to pull the -2 out as the coefficient. The antiderivative of sine is negative cosine. This is where that negative, I probably should have left it, but that's okay. The antiderivative of sine is negative cosine, so this becomes +2 cosine u plus a constant. We need to replace the u with 1/2 x again. Okay, so this is the general equation. This is the general solution to the differential equation. This is the general solution. We need to find the particular solution. So they gave us this point 0, 6. So we know that y is 6 when x is 0. And we're trying to find c. Cosine of 0 is 1. So c equals 4. The final answer to this problem is 2 times the cosine of 1/2 x plus 4. And now we have our match. Let me get a lighter color. This can be ugly, purple and yellow or orange. All right, there we go.